So, good evening, students. Welcome to this chapter 4. Uh, so, today's e-chocolate winner include Jash, the first logger, Dhyanesh, and Jyoti. So, Pranav is also there, Manoj, Mitesh Bhai. So, good evening to all. Let us start from where we left the last day. So, we were on this topic, digital payments. Let us take it one by one. Now, these are the digital payments, new methods. We talked about the old one. Now the new one, UPI apps, immediate payment service, BHIM app, mobile wallets, Aadhaar-enabled payment system, unstructured supplementary service, data, mobile banking, cryptocurrency, E-rupee. So we'll just take a brief of each of this. A fast recap is also be there based on this discussion. Let me bring the module. Okay. So first of the methods that we want to talk about is UPI, Unified Payment Interface. We've already taken a lot of examples. What I'll request that beyond what the definition part, beyond what it is working, all of you must share this figure for December 2022. If there's a question that requires you to define digital payments, then I'll request you to please add this. December 2022, the total UPI volume was 780 crore plus, and the total value of that volume was more than 12 lakh 50,000 crores. So that much value UPI is doing. Unified payment interface system, which allows all these digital payments that we are doing. Lot of examples are there. Few are there in the module. You can keep these examples. So now UPI has gained popularity, and we've already talked about that across the world. People are talking about UPI and requesting our country to create platform for their digital payments. Then immediate payment system. So before we talk of immediate payment system, it's an instant transfer, interbank electronic transfer through mobile phones. You can also do it. Means saying mobile or doing it through laptop, that m-commerce, e-commerce have merged. We've already talked about that. IMPS is an emphatic tool to transfer money instantly within banks across India through mobile, internet banking or ATM. Then mobile apps, BHIM, Bharat interface for money. So a lot of popularity was BHIM got during the first phase of the lockdown 2020. Over a period of time, it's still being used. It's a mobile app developed by NPCI, National Payment Corporation of India, and it works on unified payment interface. It facilitates e-payments directly through banks and supports all Indian banks. Then next is mobile wallets that you all know about. So mobile wallets or e-wallet is nothing but digital version of a physical or real life wallet in which you can add money to purchase goods or services. So I think we all use it. So nothing more to be added to this. The one important aspect for whatever we are discussing is security. So as we go ahead, that issue is going to come in this discussion itself. So users have to use this, and then this you can do directly payment through mobile apps. Lot of list is there. You can add more to this. So Paytm, Freecharge, Buddy, MobiKwik, State Bank, Buddy. So these are all good examples of mobile-based app. Then Aadhaar-enabled payment system, AEPS. One of you did talk about this during this chat discussion. So I did share that. So AEPS is basically right now being used for DBT, direct benefit transfer of subsidy to the beneficiary's account, and the level of subsidy that is being transferred. So it is already giving lakh crore business to more than lakh crore business to AEPS as a platform. Okay. Then USSD, we did talk about it, that even with more than 110 registered mobile numbers, still more than 50% of Indians use feature phone, which cannot use all these payment wallets. to help them use technology to do banking through their mobile phones. So this USSD platform has been created. It's a revolution. You can use it uh, on a feature phone. It basically works on SMS. Then mobile banking, we all have talked about, you know it. Yes. Now this topic comes about cryptocurrency. So what I want, see, over the period of time from the day cryptocurrency came and today, lot has changed across the world on cryptocurrency initially. So let us just define. So cryptocurrency is another electronic payment method that is steadily growing in popularity. But we'll have to add a hash here, please. And will be talking slightly more on cryptocurrency because it's an evolving technology and it has already got a lot of bad names. So I'll share what are the key issues that have come with cryptocurrency. Let us read first and then I'll request you to note something on this. So cryptocurrency is a digital currency produced by a public network rather than any government that uses cryptography to ensure payments are sent and received safely. A cryptocurrency is a medium of exchange wherein records of individual coin ownership are stored in computers database using a very strong cryptography. So a lot of controls are there in this cryptocurrency. Cryptocurrency is so called because all data is ensured with strong cryptography. So a lot of coding, cipher technologies are used to create this cryptocurrency. Cryptocurrency is a digital money which does not involve any physical coin. Since it is online, the user can transfer cryptocurrency to somewhere, making payment without going to the bank. The most popular cryptocurrency has been Bitcoin and others have gained popularity. Now, please understand, I want you to add the present status. Suppose the question comes in examination for cryptocurrency, please write these 3-4 lines that I'm sharing with you. Or what I'll do, I'll bring a Word document so that you can note it separately. We need to put these because cryptocurrency, why it was not still not a legal tender in India. So there are issues with cryptocurrency that you must all know. So let us do that. Let me share those issues with you. These are important to understand and keep a tag of. Okay, so let us bring that. Just give me a second. Yeah. So what we are doing, we are keeping a tag of issues with cryptocurrency. Why it is not so, why governments are not allowing it to be in our country, why it's not a legal tender. So just look at what are the issues with cryptocurrency. First, it does not leave a trace. Now, this could be an advantage as well as a disadvantage because you are looking at a cryptocurrency. See, government across the world found that this is used for money laundering. So in our country also, Reserve Bank of India did say that cryptocurrency still is not a legal tender in India because it has been found to be used for money laundering, drug money and hawala transactions. So these are done through cryptocurrency. So that is why that restriction has been brought first. Second, because it does not leave a trace. So identification of sender and receiver is not there. You cannot catch hold of the person who has transferred this or who has received this. And this itself has been one of the most deterring factor to allow it as a legal tender in India. And the present situation is that worldwide cryptocurrencies, whatever value they had, there is a huge value loss for all known cryptocurrencies across the world. So I'll request you to keep tag of this in examination. If they talk about cryptocurrency, please create a heading, present status of cryptocurrency. This is very, very important. Just keep a tag of it. Okay, don't leave it to that much. The benefits, please identify the disadvantages, why it is not being allowed to be used as legal tender. Just for knowledge sake, for understanding, we did talk about a word called as ransomware. So ransomware, let us do it at a cost of repetition. What is ransomware? Ransomware is where hacker hacks into your system, hacker controls your system, hacker encrypts all the important files available in your system, and then hacker sends you an email. What is an email? Hacker tells you, see, we have encrypted all your critical files, and if you want them to be decrypted, you pay us this much amount. This is ransom, vasuli. Okay, so this is what is called as ransom. Now you want to make payment to the hacker, and hacker is more than 95% of the time your system is hacked by someone who is not sitting in India. Okay, he or she is sitting outside India, probably working for an organization whose business is hacking only. Okay, so that is there. Now, how you make a payment? So, do you make payment to that international hacker through dollars? Dollar will create a trace. So, all these ransomware hackers, when they ask you to make payment, they ask you to make payment in cryptocurrency. Why? Because cryptocurrency doesn't leave a trace or a trail. That is why the governments across the world are in discussion how to create a traceability of. You cannot allow this to happen. It can create a huge disaster to sovereignty of countries. So that is why cryptocurrency is not having. It's taking its hit because of this. You could say technological advantage, but sovereignty. If you look to the security of the country, it creates a big risk. So just keep a tag of all this. Okay, so let us go to the discussion. I've got your queries. I'll answer after we go through this digital payments discussion. Okay. Then next is e-rupee. So Government of India recently came about with this, a new made of cashless, contactless digital payment named as e-rupee, based on UPI system to ensure seamless transfer of benefits to citizens in a leak-proof manner. It's an e-voucher which will be delivered to beneficiary in form of QR code or SMS string-based voucher through which funds will be directly transferred to their bank account. These vouchers are person and purpose specific, meaning if they are released by government for a purpose of vaccination, for instance, they can be redeemed only for vaccination. This contactless e-rupee is easy, safe, secure, as it keeps the details of beneficiary completely confidential. The entire transaction process through voucher is relatively faster and reliable, as required amount is uh, already stored in the voucher. So e-rupee is the next one. Okay, then so we want to go to the our PPT. So let us bring that and then we'll go to your questions. Then traditional methods of digital payment. So let us take the question. Yeah, so Dhanish, first question is email bomb. So see those, those spyware, malware, those will be delivered to your system through email. They will be referred to as email bomb. Okay. Okay, then next Manoj asks full form of CVV. That okay. So CVV is basically card verification code. So that verifies your that this credit card, debit card number, and that code they technologically that CVV is generated. So it identifies the authentication for the card, specifically known as card verification value. UPI. So Beam is based on UPI as a platform. Dhyanesh. So suppose you say, how does Beam work? So Beam works on UPI platform. That is how you look. So I'll okay. Then just as an example for a cryptocurrency, but I told you it carries its uh, own source of risk. Pranav asked, who is the owner of crypto? Now, please understand, Bitcoin is one of the most famous cryptocurrencies created. It has its value. It's you could say goodwill associated with Bitcoin. So who is the, and there are today, as I know, my whatever I say right now is subject to update every second of time. But my understanding is that there are more than 1,000 cryptocurrencies which are used across the world. So those cryptocurrencies will be the cryptocurrency is a generic name. Bitcoin, Pi, Ethereum, these are specific name of the currency. So that is how this there will be many inventors of all this. Then how cryptocurrency works? So that is say it basically works. There is a technology we'll be talking about that. So it basically creates a like a cipher code. So you transfer that code, and the way it is communicated, it doesn't leave a trail behind. Yeah, it is going to come. Manoj, you are disturbed ledger. That is part of the discussion. Okay, it's going to come. Then traditional payments we are not going to talk about. So credit card, debit card, smart card with the chip, and internet banking. Okay. Now going to advantages of digital payments. So easy and convenient, pay or send money from anywhere. Discount, yes, government to promote may give. Yes, I think there's if you're all digital transactions, then you get benefit. Then it creates a traceability return record. Less risk subject to control. So the risk in terms of physically carrying cash and losing cash, physical cash would be a greater risk, but someone takes, he or she may take your mobile, which has all the details. So that itself is also a risk. But with proper controls, you can always reduce the risk. Yes, it creates a competitive advantage to business, and COVID lockdown was the way we looked at it. It created a huge benchmark, huge volume for digital payments. Environment friendly because it uses less paper. So if you want to print paper, currency notes, you have to use paper and other non-green technology. So to that extent, this is environment friendly. Then coming to drawbacks of digital payments. Yes. So those people who are not, like I shared, that today also with so many registered mobile numbers, more than 110 crores, 50% of the people do not have smartphones. So none of those people are trained or they don't have experience of using this digital payment systems. And that is why sometimes they create errors and you read those errors. Huh? The fraud, the internet fraud, and money has been taken out from my bank account, or my credit card, debit card has been debited for a transaction I did not do. Most of that fraud occur because of the non-learning. The person who is using those technology, he, she doesn't know the associated risks. So that is the first point. Difficult for a non-technical person to use digital payments. Then risk of data theft. Yes, you must be reading this. I understand all of you have started reading the financial dailies. So every 3 months you find some information that this company's database has been hacked by hackers, and they sell this database publicly on some price also. Then overspending, in fact, third point has a lot of psychology built into it. Research across the world is being done to find the impact, emotional, psychological impact of this digital payments. And the thing is that because it is so comfortable, you can do on a click of button mobile. So people who have this, we may not call this as a say illness, or we don't call it as a disease, but there are people who love shopping, buying products every third day, seventh day, or every month they need to buy something new. It creates a huge issue with them. And you will be knowing at least one such person in your family, in your friends, close relative, close friends. So it creates that. Then disputed transaction, we have already talked of case studies that how you resolve those, because it's a learning process. So all across the world, these disputes are being created on digital payments. Who is responsible? if the digital payment doesn't go across, so your bank account is debited, but the recipient, he or she, or the website or the app creator doesn't receive it. So what happens to that transaction? So the disputes are there. At a business level, it does increase the cost, but because it leads to huge volume, so that cost is later on spread out. And last, we have already talked about internet access is a mandate. Then the topic that we want to take for today, so I'll bring the PPT. Let us see. Manjunath, so see, unified payment interface is a platform that lot of these payment gateways and technologies use. So to that extent, that is correct. I've answered that. Then I don't know, Pranav, that's a very specification. Whether pi has a value, I don't know it. Okay. So it says, yes, sir. People are mad about that. Okay. Okay. So let me bring the PPT for today, and then we'll take from that. Okay. So computing technology is the topic we'll start. Just give me a second. Yeah. It's a very big discussion. Few topics you understand, few will try to learn. Few we are going to have a very detailed discussion. One of them is cloud computing. Okay. So virtualization, grid computing, cloud computing, mobile, green computing, BYOD, bring your own device, web 3.0, IoT, Internet of Things, AI, artificial intelligence, machine learning, and blockchain. So we'll be doing a detailed discussion on this. Okay. So you're all sharing that someone who is expenditure freak. Okay. Now, so computing technologies, one of the high-end potential technologies is informatics. It is expected to revolutionize the value addition to huge information component, which is growing exponentially. Traditionally, innovations in the field of storage, mining services may be key to address the emerging challenges. So what you're basically looking at, the technologies, the way they are evolving, and please understand, because now technology is using technology to evolve itself. So that progress, that to me personally, if there is something that is much faster than geometric progression, that is how the technologies are evaluating or evolving itself. Okay. So first is virtualization. What exactly is the concept, application area, and common types of virtualization? Now, see, in this topic that we are into, there are in few topics there are a lot of technicalities built into it. So, what I'll request you, just remember those words per se, okay? Because that depth will not be needed for these for your knowledge purpose. Okay, Dhyanesh, Web3 is a part of discussion, so it will going to come. Okay. Now, please understand what virtualization is. So, virtualization means to create a virtual version of a device or a resource such as a server, storage device, or a network, or even an operating system. Virtualization refers to technologies designed to provide a layer of abstraction between computer hardware and software running on them. Virtualization allows users to manipulate their operating system into thinking that a group of server is a single pool of computing resources, and conversely allows its users to run multiple operating systems simultaneously on a single machine. So let us run through this, then I'll share with practical example that we'll be learning. Okay, virtualization. So what is the key word in this? A virtual machine, virtual location is being created. The antonym for virtual is real. We have talked about in previous chapter. when we talked about RAM, random access memory and read-only memory, and primary memory and secondary memory. So we talked about the concept of real memory and virtual memory. So I told you that real memory, that is you can define, virtual which is not real. So here virtual means to create a abstract working location. So virtual, when you say virtualization, is like creating an abstract working location. So the device may not be physically available, but the user feels that it is there. That whole idea is virtualization. I'll share a very good example on this. The core concept of virtualization lies in partitioning. Please carry this word, partitioning. This is a very important concept to understand how it is going to work, which divides a single physical server into multiple logical servers. So physical server means the, say, one physical machine. Logical means you, from this physical machine, you allow more than one people to work. So that creates a logical server. To create this logical server, the technology that is used is called as partitioning. So dividing the hard disk, the working locations logically, so that more than one people can use a single machine. Then where you can use that. So we'll take few words from the module. Let us try to create an example of virtualization for understanding purpose. So I'm sharing something we experienced in our own office some time back. So we had to do some work. To do that work, we suppose, for example, we had 3 PCs there and volume was there. So we needed a fourth one also. So I learned it. So I found that we can create a virtual machine. So what virtual machine would do, that we need not buy a CPU, but we bought a device. That device allowed one machine to be used on 2 monitors, 2 keyboards. So single machine, a single processing location, a processor, a single CPU, we created a connected CPU also. It was a virtual CPU. So it had a keyboard, it had a monitor, a mouse, and a separate person could work on that. So that was created through a concept of what you call as virtualization. So it was not a real server. The user who was our team member, whomsoever was working on that, he or she got a feeling that that computer is separate, but actually it was using the storage, the processing of an existing machine. That machine was used by another person. So this idea of creating an abstract working location, that is basically virtualization. Let us see these examples from the module. So please understand, the whole idea is that you are creating something that doesn't exist. So how you remember virtualization is that you are creating something that is not existing. Okay, now let us see. Server consolidation. So virtual machines are used to consolidate many physical servers into few servers. Now please understand what is happening, that the physical machines are multiple and you're consolidating them. Say there are 10 physical machines available. You logically consolidate them so that they appear as 4 to the user. So 4 logical consolidation may have their own purpose, intent. The downside, they may be 10 physical machines. So that becomes, that you call as consolidation. How does it help? Because if you consolidate, it is a logical consolidation. So to that extent, number of applications to be used, the way users are going to access. So for all this, you will have to give definition for 4 logical machines. Suppose you did not do the consolidation, then all definitions would have to be created for 10 physical machines. That is the last line of this. Each physical server is reflected as a virtual machine. Guest residing on virtual machine host system. This is also known as physical to virtual, P2V, physical to virtual. So 10 machines are consolidated to create 4 machines. That is. Then next is very important, this disaster recovery. Virtual machines can be used as a hot standby. Now please understand, I told you that this discussion is going to have some lot of technical words built into it. So few I leave to remember as they exist. Those which you can get it easy for understanding, those I'll explain. So this one I am explaining because this is part of the syllabus. Sometime later it is going to come again. See what happens. Suppose I say disaster. Only for example, September 2001, World Trade Center disaster. Human life loss, we have talked about. Let us go to the business part of it. So when such huge buildings went down, so they had many companies, hundreds and thousands of companies were there. Lot of servers were there, lot of server rooms were there in World Trade Center. Now it is all destroyed. So how does the company work? So when such thing happen, company has to work from what is called as off-site. Means on-site was World Trade Center, now it has been destroyed. So you are going to work from off-site. Off-site means a site that is physically distant from your normal location. Why you have to go to a off-site? Because what has happened? A disaster has hit the organization. You as an organization has been hit by a disaster. So you need to go to a different location. That is called as hot site. Now, off-site. How you configure that off-site is what is gets its name. So you have a mirror off-site, you have a hot off-site, you have a cold off-site, you have a warm off-site. So hot off-site is which can be started within a very short time of the disaster. So my on-site is hit by disaster. Within a day or two, I can start operating from the hot off-site. So that is why this virtual machine is called as hot standby. Hot standby means if there is a disaster, you can start working from this immediately or say within 24 hours, 48 hours. So that name is here. Okay. So virtual machines can be used as hot standby for physical production servers. This changes the classical backup restore philosophy by providing backup images that can boot into virtual machines capable of taking over workload for a production server experiencing an outage. So disaster is one due to work pressure. If the server may be going down, then you can use that virtual backup server for as a hot standby. Then next, sorry. Okay. So next topic is testing and training. Virtualization can give root access to virtual machines, thus providing. So those who are developers, they need to test. So you can create a separate virtual test environment. So physical machine being there, logically you create a separate test environment. So it helps those people working. Then portable applications where you can run one application on more than one system. So you need not install this application every location, but you can use it on virtual machines. And portable workspace, moving one place, one from one location to another location. Then we are continuing in the module itself. The next heading is types of virtualization. So I'll request you to remember the core headers. Hardware virtualization is platform virtualization refers to creation of a virtual machine that acts like a real computer with an operating system. So the example that I shared from my office was basically like a hardware virtualization. Okay. Then network virtualization is a method of combining the available resource in a network by splitting up the available bandwidth into channels, each of which is independent from the other and each of which can be assigned to a particular server. Now, please understand, we talked about the concept of broadband and the bandwidth as an idea. So we did talk about that. What exactly is a bandwidth? So how you measure bandwidth is the volume of data it allows to pass through per unit of time. So that is why you measure it in BPS, a million bits per second, like that, gigabits per second. So that is a bandwidth. Now, when you say network virtualization, what exactly it means? It basically means that you have an available network space, network capability. What you're doing, you're splitting up. Read this important word. What has been done? This available has been split up. So, and say the available bandwidth has been logically split into 10 points. And these 10 units are allocated to individual location servers So for those servers to which this has been allocated, this becomes their bandwidth. So that is what is network virtualization. Then one of the most used would be like this storage virtualization. Storage virtualization is an apparent pooling of data from multiple storage device. Even different type of storage device into what appears to be a single device can be managed through a central console. So storage virtualization is bringing all together. It helps the storage administrator perform task of backup, archiving, and recovery more easily and in less time by disguising the actual complexity of the storage area network. Now, this is very, please understand, please visualize this one. That suppose you are a storage administrator of a company and there are 10 servers on which you have to take backup, 10 physical servers. But what you do, you consolidate, you create a virtualization so that that 10 is only one for you. Physically, they may be 10, but they for storage purpose, it is one only for you. So when you take a backup, you have to run backup for one. Rest it is automatically going to do for the others. So that helps you save a lot of time and manage your resources much better. That is virtualization. So if the theme of the topic virtualization is what? That you create something that doesn't exist like that. Okay. Then grid computing, it's very, very, very important. Now, grid computing, introduction, benefit, types, application areas, grid computing, security. I'll share something, a very good case on this, grid computing. Let us discuss, create a definition, then I'll tell you what has been done. It's a phenomenal thing to do. Okay, so computing is the finding solution to problem through technology, through use of system. That is computing. Yes, Priyanka, virtual. Yeah, in fact, uh, lot of all this now you have public schools in metros. You have public schools in tier 1, tier 2, tier 3 cities. So tier 3 cities also big public schools are being made. So those public schools they bring uh, parents to show how the school is. So they take parents to computer lab. So there are say 40, 60 computer with they show that these are, see, our lab has 60 computers. What the parent is looking at is the 60 monitors, 60 keyboards, 60 mouse. What the parent is not looking at, how those 60 keyboard, mouse, monitors are being controlled through. So these schools are using virtualization to a huge extent. So through create for 60 computers, 60 monitors, uh, you can create that through virtualization. You need only 15 CPUs. Means you can do it with much lesser also, but just doing it, ensuring that each of the person gets at least good speed and good processing power. So through 15 CPUs, you can create a lab of 60 monitors, keyboard, and mouse. So that is, it is being used. So that was a good example to talk about. Yeah. First, this example I'm giving is hardware virtualization, this school example. Okay. So today there has been a result. So it's a very different topic, but my congratulations to any one of you who have passed, and hard luck to those who have not been. So that is the only thing. Okay. Yes, yes. In computing, Varsha, good. You can say, Mohammed, computing is calculating, but it requires a lot of intelligence built into it. I've already given congrats. I don't want to do it by name, but congratulations to all of those who passed. Great. Thank you. Uh, it's a technology, Harsh. So you use technology. Yes, 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 Mohammed. 15 CPU, 4 portals, 60 CPUs. Okay. Now going to the next topic, grid computing. Okay. Again, a good example of this. So grid computing is a network in which each computer's resources are shared with other computer in system. It's a distributed architecture of large number of computers connected to solve a complex problem. In grid computing model, servers or personal computers run independent tasks and are loosely linked by internet or low speed networks. The definition allows me to share that example I wanted to share. So across like this uh, COVID and vaccine creation for COVID has been a learning experience for the whole world. The countries across the world who created their own vaccine, including our country, India. So now see, those of you, if you read this medical or how new drugs are created, what is the process of research of new drug discoveries, new medicines being made. So there's a very large time frame that is there to create a new medicine, new drug. So there are what they call phase one development, phase two development, then phase three development, phase four. Then there's something called as clinical trial one, two, three. So phases are where the drug is basically being developed, tested in the lab itself. Clinical trial is when you start testing that drug on, say, designated animals, or then once that clinical trial on designated animal goes good, then you go for trials on human beings like that. So it's a long drawn process based on the complexity of the disease or the cure that is being sought. It can take 5 years, 10 years, 15, 20 years to develop a single drug. Now, when COVID vaccination issue came and everyone realized that COVID is so new to the world, so this whole process of vaccine discovery was like fast tracked. So how to do it fast? So not for COVID per se, but for a different medicine. Normally, to develop that medicine, say because see what is happening. Please understand what is how grid computing is going to help create medicines faster. So this time frame that I am sharing for new drug creation, 5, 10, 15, 20 years, lot of time is taken for data creation and data analysis. So what grid computing did for some drug developed, say 5 years, 6 years back, a lot of people through a non-governmental organization committed their personal computer resource for the data assimilation and data simulation. Now, please understand how I can do it. So, say, for example, in India, our office is say 10 a.m. to 6 p.m. in the evening. After 6 p.m., my office has, say, for example, 10 computers and they are free. That is a non-governmental organization that says that we are helping create a new medicine. Would you like to contribute? So I'll ask the non-governmental organization how I can contribute in that drug development. So they will say you have to do nothing. What only you have to do is that you allow one of your computer to be used by us. So my computer will be used by that non-governmental organization for data analysis. So I'll tell you, okay, so I agree. So what will happen? My office is working from say 10 a.m. Indian Standard Time to 6 p.m. Indian Standard Time. So they will say, okay, what we will do from 10 p.m. as per IST till 6 a.m. IST next day, 8 hours we are going to use your computer. What I have to do, they will send me some software. I'll download on my computer. I'll keep my internet on. My office will be closed, but my computer will be working. They will send some data. The software is also already there. That software is going to make some analysis, send back the result to the non-governmental organization who is doing medical research. Now imagine I am one person only. 6 years back when this drug was being developed, so what I know best to my knowledge, more than 35,000 people allowed their system to contribute to that medical research. So 35,000 computers working, some means 24-hour cycle across the earth. So there will be some location, there will be day, there will be night, but it is a 24-hour working when 35,000 computers are working non-stop. So that drug would have taken more than 10, 15 years to develop. The whole data analysis was completed within 2 to 3 years. That is the best part of grid computing. Now read the definition. So I'm reading it again. Grid compute. It's a computer network in which each computer resource are shared with other computers in the organization. So who is sharing? I am sharing. I am sharing with whom? The non-governmental organization. It is a distributed architecture, 35,000 computers across the world, of large number of computers connected to solve a complex problem. What is the complex problem? Data analysis for drug discovery. In a grid computing model, servers or PCs, what I have connected? My personal computer, run independent tasks. So what is the task allocated to me? Some data, some analysis from the complex has been allocated to my system and are loosely linked by internet or low speed network. So what I had to keep open, my internet open. That is the best example of grid computing and understanding what exactly it can do. So please understand it can achieve phenomenal results. I don't know, but I would have loved to share that. When I say supercomputer, okay, I'm asking this question. It may be out of course, but it's a learning question. If I say supercomputer, so there is a speed measurement of at what speed supercomputer is going to work. So there's a benchmark that any computer will only be called a supercomputer if it achieves this speed of processing. So can you name that speed in the chat? So once you answer that, I'll come back to the concept of grid computing and what it can create across the world. My question to you is, if I want to identify some computer as a supercomputer, so there is a performance benchmark associated with that supercomputer. Just name it in the chat, then I'll share something on the example I've given to you. Okay. What is the benefit? So the example I've shared, in fact, you can, based on this example, everything can be discussed out here on grid computing. Making use of underutilized resources. What is underutilized? My computer is idle for 16 hours of a day. It is being used. Resource balancing. Yes, I allow my computer to be used when we have night in our country. So suppose when we have night, say US or South America, they will have day. So when they have day, so because it is a computer that is contributing to the research, but it's office time, so that computer is shut down, but mine is there. So the load is balanced. Parallel CPU capacity. It brings the capability of all the CPU together. Virtual resource and virtual organization for collaboration. So this roughly 35,000 people who contributed to that research, they all became part of that drug discovery, and it's a learning thing. Access to additional resource. So someone who was, say for example, WHO would have been doing that research. So WHO get access to so many computers and reliability. Yes, based on the technology, based on security, you create reliability and better management. Yes, so yes, Mohammed has teraflops. So the benchmark is teraflop. So you call it supercomputer when it has this, at least 1 teraflop is speeds. Okay. Lent, I've got the correct answer. I'll use it once we complete this benefit part. Okay. So just imagine that for that non-governmental organization with 35,000 computers contributing to medical research, their parallel CPU capacity has been brought together. So that must have created a supercomputer whose capacity would be, say, 10 teraflops. So that is like 10 supercomputers working together. That much capability you can create to grid computing. It's a phenomena. Yeah, teraflops. Yes, so Pranav asked a very good question, how they were using my computer. Because Pranav, it is like I want my computer to be used for a good thing. So I allow it to be used for good cause. So I allow that organization to use my computer. Now, when they can use my computer, there are 2 or 3 conditions. First, I must keep my computer on. Second, I must keep my internet connection on. Third, they are going to send a software which I need to install. Fourth, I will give them time that this time you can use my computer. Fifth, they are going to send data or whatever analysis that has to be done on the software during the time I allow. So it is, they are only able to use Pranay when I have allowed. If I didn't allow, they will not be able to use it. But roughly 35,000 people across India allowed it to happen. Across the world allowed it to happen. Why? Because they wanted to contribute to that drug development, drug creation, drug discovery. That is why. Okay. So a grid is a collection of machines, sometimes referred to as nodes. So what I am becoming, my machine becomes a node, members, donors, clients, hosts, and any other system. What it includes: computation capability of my computer, storage of my computer, communication through internet, software. I've shared that they download a software and issued licenses. There could be special equipment capacity, architecture, and policies to be followed. Yeah. So let me go to the next slide. Then Alok's point I'll take. Yeah. Okay. So I'll read all of in grid computing. They are using our computer. Yes. So they are using our computer for processing their data. Alok, I'm improving the sentence. So in grid computing, what is happening? The example I gave you, they are using my computer for their data processing. Computer is mine, data is theirs. That is how you look at it. No, Mohammed, not each time. You give it for a specific. The example I have shared. What I know, all these 35,000 people gave their computer to be shared for 6 months. You can do that, but then every time 10 p.m. in the evening, why you want to wake up and then give a approval? You give a one-time approval to them like that. Okay, Pranav. So that is what the technology, that is, Pranav, what the question you have asked is the header of the slide that you call as grid compute. So, okay, just for the sake of it, if you say parallel, so what happens when you create a parallel processing? So it adds to speed. Okay, a lot of data you can process parallelly. Beyond this, it will go into physics, Pranav. So leave that. Okay. So just understand that when many computers work together, their parallel capacity is very high. Okay. So leave beyond it. Okay. Then application areas, civil engineers, bring people together. You can create design like that. Insurance company means, see, these are applications which people have actually used it. The one that I have shared is not there. Please add it. Application service provider, enterprise configures external, internal resource to balance their business workload. Large scale science and engineering are done through interaction of people, heterogeneous computing resources, information system, and please add drug discovery through use of grid compute. So add this. Yeah, Parthsarthi. So software is deleted. So it happens inadvertently that you may delete a software. So whenever you delete a software or an application file or a file extension .dll, there's a security built in your system. What happens? I'm asking you, Parthsarthi, what happens when you give by mistake press delete button on a file? Does system ask you something? Please write that. That is answer to your query. Okay. Now the security aspect is there. Exactly what Parth. No, Mohammed, before you take it to recycle bin, does it say something? Yes. Every time you want to delete a file or a very application program with .exe, .com or .dll extension, .dll I think you cannot delete. .com, .exe you want to delete, system gives you a warning that do you want to delete this? So it may also makes you aware. Still, by mistake, you press that delete, then probably it may go to recycle bin. And even if it is deleted, say permanently, then you can always go back to the NGO and request them that I still want to contribute to the research. Please resend the software. So it can be always done like that. Yeah. Are you sure you want to delete it? Yes, exactly. So, Kujema, Alok, everyone has said correctly. Yeah. Then, now, while I was discussing, there had to be one question that I was expecting from all of you was that this idea about keeping my computer on, keeping my internet on, allowing a third party to access, all these have to create a different category of risk, that is security. So you just see that security is the header of the slide, that whenever you talk of grid computing, security is one thing that has to be very, very foolproof like that. So you require firewalls, you require access controls, everything has to be built because that uh, is very, very important. So secured resource management, data management. Resource management means because that technology is going to use your resource. So you need to ensure that the appropriate timing is there. Data management, management and protection of credentials. Yes, see, that person is going to access your computer. And if he or she is able to gain access to some critical information saved on that, or reverse is also possible, that the person who is using the computer for research, he or she leaves something critical on your computer and you think of misusing. So that is very, very important. Interoperability with local security solutions. Two systems interface for critical operations, so that security has to be like which can be used on all systems. Standardization of the way of doing it. Exportability of data. Support within system and support for multiple implementation of the same system. What exactly, Pranav, you asked? So you can do it more than once. Yeah, look, you can put restrictions, but if you put restrictions that you can only view and not edit, then the software will not work. So, of course, so when you see, if you're allowing your system to be used for something that is good like this, so there is going to be what you call as a agreement. So that agreement will have condition what you can allow and what you cannot allow, and what you can restrict and what you cannot restrict. So it is there. So Rekha has uh, sent thanks to a faculty. So I'll request you to please send a mail to the institute also. They will also feel good. Okay. So that is great computing. Now, one of the topic that we are going to talk a lot is cloud computing. Okay. Lot of discussion, lot of technology, lot of learning, and lot of questions in examination. So we'll be talking about cloud, reasonably detailed discussion. To understand cloud computing, we first must understand what is cloud. So the cloud refers to application, service, data storage on internet, and we all are using cloud. Please understand, we are using cloud. In fact, when we started chapter 1, I had asked you a question to name a technology that you feel will be used in future. So a lot of you tried to give answer on cloud, artificial intelligence. Someone did talk about machine learning. Someone did talk about blockchain. So all these technologies are actually being used. So, and cloud is one of all the examples we have talked about, this is one of the most used one as of date. Okay. So we are all already using cloud in some form, like your email access through your web browser. You're using a form of cloud computing. If you're using Google Drive application, you are using cloud computing. There's something called as AWS, Amazon Web Services. It's a cloud service provider. So companies are using cloud. You are using cloud inadvertently. You may be knowing or not knowing, but we all are using cloud. Let us go ahead. Kujim, I don't think you can do grid computing with mobile. I'm sure. Okay. So cloud computing simply means the use of computing resource as service through network, typically the internet. Cloud computing users can access database resource via internet from anywhere for as long as they need. Cloud computing is both a combination of software, hardware-based cloud computing resource delivered as a network service. Cloud computing provides the facility to access shared resources and common infrastructure. Now, one thing that I want all of you to pick, just giving a single word to cloud computing. The word is in the last line, sharing. So if you create a shared resource, you are looking to cloud computing. Let us read with this. Cloud computing simply means use of computing resources service through networks, through internet. So sharing will be done through internet. Cloud computing users can access database resource via internet from anywhere. So if you have internet, you can share database. That becomes, so database becomes shared. Cloud computing is both combination of software and hardware based computing resources delivered as a network service. So when you are using cloud storage, what will be cloud storage? That the server or the hard disk where you have stored data is not with you, is with the third person. So you are using that third person's shared resource and you are using it through internet. So it includes the technology and it includes the physical hardware, even if it is shown to you as a cloud storage. So shared resource is key, and a common infrastructure. So that hardware location, the network that connects to that server becomes a common infrastructure. Then cloud computing allows companies to scale up to massive capacities in an instant without having to invest in new infrastructure, train new personnel, or get license for new software. Cloud computing is benefit to small, medium-sized business based on pay for what you use model. In fact, these two lines on the screen are one of the key, you can say, USPs for cloud, that when you start using cloud infrastructure, you as a company need not expend money on creating your own hardware, creating your own internet, creating your own firewall, creating your own security, creating a whole bunch of people like system administrator, security administrator to manage that. So having hardware is one part, managing is another part. But when you start using cloud, so you are using a shared resource that is available on net. So all servers, all data is on the shared resource. What you have to only do is, suppose your requirement increases. So you say, okay, from tomorrow, we want 10 passwords, 10 new users to log into your system. So the cloud service provider, the agency, the company that provides you cloud service, they are going to charge you for 10 people from tomorrow. Today, say you are using only 3 people. So next day or next month or next 3 months, next 6 months, if your business grows exponentially, you will be in capability of using, expanding it through cloud network. That is very important. In fact, this discussion brings something extra to cloud, that you can do it in a very fast time. The turnaround time to scale up for cloud computing is very, very less, because you have to just create more users and get that license of use from your cloud service provider. Very, very, very important discussion. Now, so because today has been exam result, so let us just review. So suppose this question comes in examination, write down the characteristics of cloud computing. So what is going to be your para 1? The question in examination is, write down the characteristics of cloud computing. What shall be your para 1? Okay. So what I'll do, I'll run through the characteristics slide and then we'll define it in the second stage. So elasticity, scalability, pay-per-use, on-demand, resiliency, multi-tenancy, workload management, wide range of network access capability, achieve economies of scale, reduce spending on technology infrastructure, globalize the workforce, streamline business processes, reduce capital cost, ease of access to information application, pervasive accessibility, backup recovery, monitor projects more effectively. Yeah. So that is advantages. These are correct. So let us take characteristics first. Yes. So define what is cloud computing. So I've got the answer from Mohammed and Khujema. Great. Now, characteristics. So elasticity and scalability. Elasticity means whatever cloud you're using, whatever number of users you are having today, based on the need, you can scale them up. Elastic means the flexibility of doing it. So if the example I gave you, that today you are using 2 or 3 users, Tomorrow, next month, you want 10 more users, you can directly talk to your cloud service provider and get access to that 10 additional users. Pay per use. So today you are using 3, you will pay for 3. Tomorrow, next month, 3 months, you start using 10, you will pay for additional 7. Pay per use on demand. Today 3, next month 7 more. So you can get additional users on demand. Resiliency. Resiliency means capability of working, resilient. So cloud creates that resiliency because you can increase, reduce the number of users. System is being managed by a third party. Multi-tenancy, more than one type of clouds you can create. Workload measurement. You can distribute work, create more cloud based on the need of it, and wide range of network access capability. So these are the characteristics associated with cloud computing. Then advantages of cloud computing. Yeah, so definition is what is expected. So all of you have given it correctly. Now going to the second part, advantages of cloud computing. Achieving economies of scale. Economies of scale means you create it based on the requirement you have. First. Second, if your requirement goes like it increases in geometric progression, then you can increase to that level. So that is going to help you manage your costs very well. You need not expend much on technology infrastructure. So from 3 to 10, 3 to 100, 3 to 500, your technology infrastructure spending will be limited to the extent of creating the access devices to the creating accessibility option. Rest, you need not pay for networking, you need not pay for server, you need not pay for database, you need not pay for the security administration. Everything is managed by the cloud service provider. Globalize the workforce. Now, globalize the workforce means cloud allows you what you may say accessibility from any location. So if accessibility is there from any location, your people can work on move, they can work as per their needs. So that globalization comes into being. Then streamline the business processes because you are going to use cloud. So streamline the business process means what? That whatever you are doing, you can create SOP, standard operating procedure. You can create something called as steps of doing it. You can create definition. You can train your users. So all this process streamlining you can do through cloud, because what you have to only do is, suppose you are using 3, you have 3 users today and 10 next month. So you have to only train the 7 how they are going to use the cloud. Start doing it. Reduce capital cost. Yes, capex is virtually nil. Ease of access to information application because you can access. Pervasive. Pervasive means all prevailing. You can access it 24/7/365 days from any time through a defined device. That is accessibility that cloud allows you to have. Backup and recovery. Yes. Now I'm using a word. Please carry this word. This is very, very, very important. So I am the user and here is a service provider. So user and service provider have an agreement that is called as service level agreement. User of cloud and service provider of cloud have an agreement that we call as a service level agreement. Just for the sake of reference, when I say service level agreement, one of the auditing standard that I recall is SA 402. SA 402 is what? Just give me the name of SA 402. So what you have, the user of the cloud and the provider of cloud, and they have a service level agreement. Now, let us understand one of the disadvantages that may probably coming in your hand, in your mind. If I'm the user and there's someone who is providing cloud, and what is cloud? A shared resource. What cloud includes? A server at a third party location. What I'm doing, I'm storing my data at third party location. So secrecy of data is one aspect that is going to come in later discussion. But what happens when suppose there is a disaster at my cloud service provider? Got my point? So if there's a disaster at cloud service provider, I may be hit. So when I create, as a user, I create a service level agreement with my cloud service provider. There's a very specific para page on the header of this slide, first point of the slide regarding backup and recovery. So we ask the cloud service provider, how do you take backup? What is your backup frequency? what is your data recovery center, disaster recovery center, how you manage it. So because it is part of my service level agreement, I need not put money effort into creating a backup infrastructure. It will be provided by whom? My cloud service provider. Very, very, very important. Suppose I am not using cloud computing, then what I will have to do? Create backup at my company, create separate process for backup, create a policy framework for backup, take backup as per the policy framework. Then I have to store backup. So storing backup has to be at offsite. Then once you take backup, there is a concept of recovery of backup as given in the slide. Recovery of backup means what? That suppose there is a disaster, you will have to recover your data from that backup taken. So you do not wait for a disaster to happen. You do a test run that whatever backup I have taken, whether it is recoverable or not. So all these considerations are taken care between when you have a service level agreement between the user and client service, the cloud service provider. Everything, every aspect is taken care by whom? The cloud service provider. That is backup and recovery. Then, because you can scale up, the scalability is elastic. It allows you to manage your projects more effectively. Because it doesn't have much technical inputs to that. You can start using cloud technology with minimum amount of training. Because you are not having database, not having server, not having network connection to that extent, the maintenance cost to that extent is reduced. Load balancing, distribute work as per the requirement, and improve flexibility of performance, evaluating what is needed and what further has to be done. We'll come to drawback because I asked the question. Let us review it. Okay, SA 402 is not in syllabus. Sorry. Yeah. But Harsh searched it and said it. Audit consideration relating to an entity using a service organization. Priyanka also said it. Audit consideration relating to using a service organization. So just understand. I'm creating a case for you. It's a learning thing. Okay, this SA 402. Let me do it. I am the user and here is a cloud service provider. All data is kept where? At cloud service provider. I have an auditor. So auditor is going to ask about internal controls. Auditor is going to ask about internal controls of my data. Where is my data? My data is kept where? At the cloud service provider. So my auditor is going to ask me how controls are working at your cloud service provider. That is the header of the standard SA 402. Now read it again. The audit consideration relating to entity using a service organization. So I am the entity using a cloud service provider. So this is SA 402. It's a phenomenal standard to read through. Huh? It's a fantastic standard. Okay. So backup and recovery. Okay. They monitor projects effectively. We have talked about this. Drawback of cloud computing. So internet security, internet accessibility is a concern. Security is a major concern. Now, what we want to talk about security in some more detail. We want to create parameters to security. Okay. So what you write in the chat box, security of data. So what are the aspects that you are going to review? You are going to think that when you imagine the word security in terms of cloud computing, it's a drawback. Okay. Think what is the worst possibilities with security. Write in the chat and then we'll discuss security again. It's a very important word to talk about. Okay. Then. Although I'm reading third one, security we are going to talk about again. Although cloud computing supports scalability. Scalability means increasing the use as per need. It does not permit the control on these resources as these are not owned by user or customer. Yes. Who is the owner? The cloud service provider. All this, the point that is being made, all this will be regulated through what? the agreement. Please understand, this is a very, very important document. Always remember it. Service level agreement between the user of the cloud and the provider of cloud. Then, depending on the cloud vendor or provider, customers may have to face restrictions on availability of the applications, operating systems, and infrastructure option. Now, please understand what is the point being made. The point being made is, suppose the cloud service provider says that you can use my cloud for 10 hours in a day. आप मेरे क्लाउड को दिन में 10 दिन ही यूज दिन में 10 घंटे ही यूज कर सकते हो और महीने में 4 संडे को बंद रहता है. वो अपना इंटरनेट ही शट्स, द सर्विस प्रोवाइडर शट्स द इंटरनेट कनेक्शन. So that becomes a restriction. Okay. So just because internet connectivity is a major issue, that cloud service provider is going to expense cost if he or she is keeping the accessibility 24/7/365. So he shuts down the internet then. Then interoperability is an issue. Now, what exactly is interoperability? Suppose you are using a cloud service provider, say name A, and tomorrow you want to shift your applications from A to a cloud service provider B. So this interoperability becomes an issue. Okay, good. So I've got answers. Yes, fantastic. So Jyoti, data leakage. Just understand, see, security. Security is a single word and you have all answered correctly. Huh? It has so many parameters built into it. Why I wanted to discuss is like this, because I wanted you to feel the intensity of the word security. Let us read. So data leakage, then Manjunath says data leakage. Priyanka, data may be misused. So data misuse. Manjunath again says data diddling. Now, data diddling is part of the, I think probably we'll find it in some chapter. Data diddling is where the hacker tries to modify data before, during, after processing. Where the hacker tries to modify data before, during, after processing. That is also concerned. Great. Confidentiality says Khuzema. Then Bharat says virus. Yes. Manjunath again puts a technique called as salami. Salami is to cut. I think this we have talked about then in the previous sessions. Confidentiality, Pranav says. Alok says, okay, delete of data, deletion of data. Dhyanesh, data and privacy protection. Yeah, no, Uday, cloud service provider charges for it. So they'll, but suppose a hidden charge. Okay. Yes, Piyush says data may be hacked and sold to third parties. Kojima says ransomware. You get, so security is such a critical concern. So it's a very, very important understanding for cloud computing. Then, now we want to talk about this in detail. The cloud computing environment can consist of multiple types of cloud based on their deployment and usage. Such typical cloud computing environment catering to special requirement includes private, public, hybrid, and community cloud. It's a very important topic to discuss, understand. So what we are doing, we are taking a break. It's 19.18. So let us take a break. So we are having a break and we'll meet at 19.28. So our break starts now. deployment and usage. Such typical cloud computing environment catering to special requirement includes private, public, hybrid, or community cloud. Let us take their details. So private cloud, public, hybrid, and community. So we'll take one by one. I'll bring the module. They are these clouds. So we are taking types of clouds, first starting with private. This cloud computing environment resides within the organizational boundaries of an organization and is used exclusively for an organization's benefits. So this is basically for the organization itself, its own employee. You may also call this as internal or corporate cloud. Say, for example, in India, we have companies size of 2 lakh, 3 lakh employees. So they create their own internal cloud. Private cloud can be either private to an organization or managed by a single organization, or it can be managed by a third party. So if I am the organization, I am managing my cloud, then it's on-premise private cloud, or I can outsource it to a service provider that become outsourced private cloud. But even if I outsource, because the ownership, everything remains with me, it's for my purpose only. So it is private cloud. Then what are the characteristics? So this is important, and just keep your eyes on this aspect. Key characteristics of a private cloud, important for discussion and important for exams also. Okay. So private cloud is secure. Okay. Now see, if you read these characteristics, they need to have a comparative basis. Secured against whom? So they are more secure against a public cloud. So just keep that. So always have this analysis built into the discussion part. If I say secure, then you must ask secure against whom, in comparison to whom they are more secured. So they are more secured in comparison to public cloud. So that is how you are looking at these characteristics. The private cloud is secure as it is deployed and managed by the organization itself. Hence, there is least chance of data being leaked out of the cloud. Now, just from the previous para, we talked about that you can have a outsourced private cloud also. So if you have an outsourced private cloud, this risk is there. Got the point? So this is how you learn. This is how you create value addition to the discussion. So if my cloud is outsourced private cloud, then security becomes an issue. If it is on board my own private cloud, then it is taken care of. It is not an issue to consider, not an issue to give much weightage. Okay. Then central control. As usually the private cloud is managed by the organization itself, there is no need for an organization to rely on anybody and is controlled by the organization itself because I have it with me itself. But again, if you read the words here, as usually, what is unusual that I may have outsourced private cloud. So if I'm going to have an outsourced private cloud, this is not going to exist there. Next. Weak service level agreement. Service level agreement, I shared that word with you, play a very important role in any cloud service deployment model as they are defined as agreements between the user and the service provider. In private cloud, either there is no SLA or even if it exists, because the user and service provider are in the same organization, the service level agreement is weak. Now see what we can do, we can improve the header. You know what header I want? Suppose I say you improve this header. What you want to add to this? So I want to add to this header is this word, on-premise. So this is characteristics of an on-premise private cloud. Because if you create a comparison with outsourced private cloud, then none of these issues exist, or it's an antonym. So characteristics of on-premise private cloud is secure, central, weak service level agreement. Characteristics of, you can say, outsourced private cloud is the security is an issue, the control is not central, and because it's an outsourced private cloud, your service level agreement will be very strong because you're giving it to a third person. So it just, by using the antonyms, you can create two parameters to characteristics, one for on-premise and other for outsourced. Then this is good advantages of private cloud. It improves average server utilization because it is within the organization, allows usage of low-cost servers and hardware while providing higher efficiencies, thus reducing the cost that a greater number of servers would otherwise entail. So by using private cloud, you can improve efficiency. Then it provides a high level of security and privacy. Internal, so security per se is very high. To the user, as private clouds is private, it is not for public. It is small and can be controlled well within the organization. So these are key advantages of private cloud. Moreover, there is a limitation, is that IT team and in an organization may have to invest in buying, building, managing the cloud independently. In fact, if you are having a private cloud, one of the advantages we talked about in cloud computing may not be there, the concept of low infrastructure investment. For having your own private cloud, you have to have incurred cost on CapEx also. So that becomes a sort of a disadvantage or limitation. So if you are having your on-premise private cloud, then the cost advantage, the infrastructure cost advantage probably doesn't exist. That is. Then public cloud, but you have questions, so let us read. Good, Pranav. So I need to give this e-chocolate to Pranav for this question. Fantastic. I'll read. Yes. So what Pranav has said, that if a cloud is not outsourced, then how it is a cloud? Good question. So please understand, Pranav. Imagine an organization like Infosys or TCS or Wipro, Tech Mahindra. They have more than 1 lakh employees, each organization. So I have got, say, 2 lakh, 3 lakh employees in my organization. And all these people in my organization are going to do some work, do anything in the organization. Now they need to access data, they need to access database. So what I do for these internal or these employees of the company, I create an internal cloud infrastructure. So me as a company buy server, install network, and allow access to my employees internally. Why I do it? Because if I go for outsourcing, probably the cost will be so high that I'll not be able to manage 3 lakh employee rent per month. So in that cost, I can create my own internal cloud environment. So there is this cost benefit advantage is also built in this decision making. Now, even if you have it on internal servers, why you say it is cloud? Because you're allowing the working methodologies the way cloud is working. So that is why this word cloud goes to those people also. Okay. Now, coming to public cloud, see this Google, Amazon Workspace that we are all talking about, that we all use. These are best example of public cloud. They are public cloud. The public cloud is a cloud infrastructure that is provisioned for open use for general public. It may be owned, managed, and operated by separate businesses, academic or government organization, or some of them. For Google and Amazon Workspace as good examples. So they are they are owned by private statutory or private entities, corporate bodies. Typically, public clouds are administered by third parties or vendors over internet, and services are offered on pay-per-use basis. So we are all using it. In fact, I don't know whether you know it, but like Gmail, so Google Workspace has been made into a paid account. So previously we had many users, but they were not paid. Now it has been made a paid account. So we have to incur per month cost for using Google Workspace. So that becomes our cloud infrastructure cost. There is another name for public cloud, provider clouds. It consists of users from all over the world, wherein a user can simply purchase resource or hourly or based on the parameter of billing. Like in India, hourly billing we don't have here, but we have monthly billing right now. Public clouds include Google, Amazon characteristics. So highly scalable. Scalable means because you can buy pay per use basis. Or affordable, the general cost will be low, less secure because they are offered by third party. So that security issue comes here also. And the third party will have access to full control. In fact, just for the sake of it, uh, suppose there is a data loss at a cloud service provider and it is a critical data. And the company which is using the service, cloud service provider, they want to sue the company or bring charges against the company for data loss because the cloud service provider lost data and say backup is not there. So that issue is very critical. Who is responsible for them? So that security issue comes. Then it is highly available because anybody from any part of the world, she can access that. So accessibility is very important. And this is the most important aspect for this stringent service level agreement. When we started cloud, one of the words I shared was service level agreement. In fact, in this whole discussion on cloud computing, service level agreement is one of the most critical aspect to talk about, consider. Okay. As the service provider's business reputation and customer strength are totally dependent on cloud services, they follow very strict service level agreements and any violations are also avoided, the service provider. So these are the, you could say, characteristics of public cloud: scalability, affordability, low security, high availability, and stringent service level agreement. Then what are the advantages? Now, again, when you say advantages, always have this comparative in mind. So advantages against, say, private cloud. It is widely used in development, deployment, and management of enterprise application at affordable costs. Since public cloud shares same resource with large number of customers, so the cost is spread out. So per individual cost becomes very low. It allows organization to deliver highly scalable and reliable applications rapidly and at affordable cost. There is no need for establishing infrastructure for setting up or maintaining the cloud. We have talked about this. Public cloud can easily be integrated with private cloud. So if there's a public cloud you are using and you are also using a private cloud, you can bring them together. Strict service level agreements need to be created, and there are virtually no limit on number of users which you can create on this public cloud. There is one limitation. Limitation is security assurance and creating trust, because all data is with public cloud. So this is the important consideration. Yes, Google is also charging. Gmail is charging for if you use more than 30 GB, you have to pay so extra money for extra storage. Yes, yes. So nothing is free now. Okay. Then hybrid cloud. So hybrid, as the name indicates, what has been done, the advantages of private and public have been brought together to create something that you call as a hybrid cloud. This is a combination, both at least one private and one public cloud computing environment, usually consisting of infrastructure platform application. The usual method of using hybrid cloud is to have private cloud initially, and then for additional resources, the public cloud is used. Okay. So what the discussion is that how you reach a status of or state of hybrid cloud. So how you're reaching a state of hybrid cloud is that initially you create your own private cloud, but as volume and work increases, then for additional, you start going to public cloud. The hybrid cloud can be regarded as a private cloud extended to a public cloud. So it's an extension that goes into public domain and aims at utilizing the power of public cloud by retaining the properties of private cloud. So you can always say that The whole idea behind hybrid cloud is that allow the advantages of public and private to merge together. That is the core idea. The organization may perform non-critical activities on public cloud. Why non-critical? Because security is an issue. While critical can be performed on private cloud. So all things are taken care by. It is typically either offered in two ways. A vendor has a private cloud and forms a partnership with a public cloud service provider, or a public cloud provider forms a partnership with a vendor that provides private cloud. So it can be both ways. So private, public, and this becomes the hybrid cloud structure. Characteristics now. So because it is going to bring the parameters for public and private both, so you can bring the advantages or characteristics of both together, public and private in hybrid cloud. Scalability, so I'll not be reading them. Okay, scalability. Partially secure. In public private, you use the word security. Less secure, more secure. But now because they have been merged, so a mid word has been found, partially secure. Stringent SLA. So service level agreement is strict because you will be using a public cloud. And yes, this is the key, you can say, criticality of hybrid cloud. The management of the cloud structure is, it becomes really tough. That is. Because see, you have to consider what aspect you need to use on private, what aspect you need to take on public. So that decision making becomes tough. What aspect means what information, what data, what application you need to segregate. That is the point. Advantages are scalability, better security. Limitation is that security features are not as good as on private and complex to manage. So, so if suppose you do a ascending order, okay, you do it. I am giving you this descending order for security. So at the top, you have to put the one which is most secure, less secure, and less secure. So the options are you have between private, public, and hybrid. So you have to draw a descending list of the three, which is the most secured, then less, then less. Once you write that, then we'll read this limitation of hybrid cloud again. So what you are answering to me is the security in descending order, starting from the most secure from private, public, and hybrid. Once you answer, we'll come back to this limitation again. Okay. Then you have put something more. I'll read after we complete the community cloud. Now, what exactly is a community cloud? So we'll try to create some live examples for this. The community cloud is a cloud infrastructure that is provisioned for exclusive use of specific community of consumers from organizations that have shared concern. Like just for example, let us read mission security requirement policy, compliance consideration, like GST WhatsApp group, GST software compliance, GST software group, GST cloud, Tally cloud. So where those people using same technology may have shared concern, they use community cloud. It may be owned, managed, and operated by one or more organization in the community, a third party, or some combination of them. The core idea behind community cloud is that it is going to cater to same category of people. So community could be, say, Tally users, a specific GST application user, SAP user. So that becomes a community cloud. This model is suitable for organizations that cannot afford a private cloud and cannot rely a public cloud either. So those who are not falling in this, any one of these categories may think of going to community cloud. What is the chief characteristics of community cloud? They are collaborative, distributive, managed maintenance. In this, no single company has full control over the whole cloud. This is usually distributive and hence better cooperation. You can always use a word for learning, cooperative cloud, like that. Partially secure because it's more than one person is going to use, and it's going to be community. But because it's a restricted community, you don't call it as public. So if it is not 100% public, the security becomes partial because it is to some extent private also, because community is specific. So that is why partially secure. Cost effective for all these. So this is a good key character advantage, cost effectiveness. Then Advantages of community cloud: it allows establishing low-cost private cloud, collaborative work, sharing of responsibility, and security is better than public cloud. So let us read your answers on the yes. Good. Kalo private hybrid public, Jyoti private hybrid public, Kusema private hybrid public. So that is correct. Private hybrid public. I'll read the name of who you have answered correctly. So Dhanesh, Piyush, Pranay, Hima, Bindu, uh, then Harsh, Khushi, Manoj. Yeah. So private, then everyone has answered correctly. Great. Then let us go to our slide. Yes, you can add Harsh for learning. You can. Harsh has, I was thinking of asking that, but Harsh has already prompted. So why don't we write all the four in descending order of their security? So please do it. Okay. Then computing model. So a key to remembering this lot and lot of detail is there in the module. In fact, if you read cloud computing as a part of a chapter, then most of the content in cloud computing is on this one, service model. So we'll create a one-line definition for all type of models and then read the details of it. Okay. So introduction: infrastructure as a service, platform as a service, software as a service, other cloud service model. Now, please understand the computing or the service model, the name it takes is basically from the resource that is being shared. So if infrastructure is shared, IaaS. Platform, that is OS, is being shared, PaaS. If software is being shared, SaaS. Network is being shared, NAAS. Database is shared, DAS. So that is how this all computing models are created. A single line definition to understand how this computing, this definition, the names have been created. Okay. Now, see, you have answered, so I'll come back to that after coming to the next year. Then these are the other computing models: CaaS, communication, data, security, identity. So whatever aspect you are sharing, that gives the name to the computing service model. Okay. Now let us read this from the module. So we'll go to the module. The core are these three. Please understand. The others are like add-ons, specialized categories, but these three are the core: infrastructure as a service, platform as a service, and software as a service. Then all the others are going to be add-on to this. Okay, but let us read your answers. Yes, yes. So I'm doing that, Harsh. So private is correct. Now, the only confusion we are trying to understand, it's a good discussion to have. The communication, the confusion is between having hybrid and community, which is going to have a better security. So what I'll be doing, I'll be putting community first. Simply understand, community is because it is going to have better security because it is within the same community. So risk to one person is like a risk to others. So they are going to ensure it works in a secured manner. So I'll put community after private, then hybrid, and then public. So that is how I read it. But it's a learning discussion. Okay. So let us read about infrastructure as a service. So we'll just take the quick definitions for them. I'll read the keywords. Okay. It's a hardware level service, provides computing resource such as processing power, memory, storage, and network for cloud users. So it's basically providing hardware. Okay. Now, when you use IaaS, you create VMs, virtual machines. We talked about virtualization at the start of this chapter. Then, please, this is important. This may be asked in examination also. Characteristics. So chief characteristics are access to resource through web, centralized management. You are reading IaaS. Centralized management, elasticity and dynamic scaling based on requirement. You can create more resources. Shared infrastructure. The name of the cloud service model is IaaS. So infrastructure becomes a shared infrastructure. Metered service. Metered service means whatever is used, that will be billed separately. Now, within IaaS, number of subcategories have been added. So I'll just read the name. I leave you to read the description. I've already told you how these core definitions have been created, where network is a shared thing. You call it as NAAS. Okay. They've given examples that we can all talk about. Then, so network as a service. So it is ability given to end users to access virtual network services. The best example is VPN, virtual private network. In fact, okay, bandwidth on demand, mobile virtual network. So that becomes NAAS. Then storage as a service, STAAS. Its ability to give end users to store data. So that is STAAS. Then database as a service. So DBAAS. Ability to allow end users to access database. So within infrastructure, these categories have been made. Okay. Backend as a service. So the backend support, the backend cloud storage is given as a service. Desktop. It's a pay-per-use model service delivery in which this service provider manages the backend responsibility like data storage, backup, security upgrade. So that becomes desktop as a service. Just remember the keywords, okay, not beyond this. So that is subcategories within infrastructure as a service. Next is platform as a service. Okay. So PaaS provides the users the ability to develop, deploy an application on the development platform provided by the service provider. In traditional application development, the application will be developed locally and will be hosted on central location. In standalone application development, the application developed by traditional system result in licensing based software, whereas PaaS changes the application development from local machine to online. PaaS provides a pre-built computing platform consisting of operating system, programming language, database, testing tools. Apart from build tools, the software developers can develop and run their software solution on cloud platform without incurring cost and complexity. For example, Google App Engine, Windows, Azure, these allow you to develop online. So once you develop online, you can use it for your, so that is platform as a service, PaaS. Then the one that we all are familiar, the one that we are all using is SaaS, software as a service. So all softwares today licensed, which are basically per user rent basis softwares, are SaaS, software as a service. It provides ability to end users to access an application or internet that is hosted and managed by service provider. In fact, most of the big software companies have already adopted this model, SaaS. The users are also adopting this model. Thus, the end users are exempted from managing or controlling an application, the development platform, and underlying infrastructure. So that becomes SaaS, software as a service. Then, what are the further usage of software as a service? Testing as a service, tasks. So this provides users with software testing capabilities. Then API as a service. This provides users, so application program interface we are developing, so they can use this. Google is providing a lot on this. Email as a service. So within SaaS, you can have these three words: PaaS, API, email as a service. And then other cloud models. So I'll not be reading this in detail. We'll take the keywords. Okay. Communication as a service. It's an outsourced enterprise communication solution that can be leased from a single vendor. So to that vendor, it becomes the user, it becomes communication as a service. It allows businesses to selectively deploy communication devices as per their need. Then data as a service. This provides data in demand to diverse set of users, system or application. The data may include text, image, sound, video. So how you are managing it, that becomes your service. Security as a service. Yes, it is ability to give end users to access security service provided by the service provider based on the need of the user. So that becomes security as a service. Identification. Yes, this is actually done. It is an ability of, just give me a second. It's an ability of given to end users to typically an organization or enterprise to access the authentication infrastructure that is built, hosted, managed, and used on a third party system. So there it becomes security as a service. Identification of user by third party systems, IDAAS. Okay. Then we'll come to this. There are few questions. Let us go to the slide and we'll take the questions. Yeah. So Kozema has a question. You can add Kozema. So it's a discussion. It's a learning discussion. Okay. Yes, LinkedIn you can take there. Communication as a service. Okay, you can take that, Kozema. Okay. Let me refresh. Okay. Now, pertinent issues. Pertinent issues means those things that we need to consider. Those we need to remember, keep track of. Those are pertinent issues. So, threshold policy. Now, what exactly is threshold policy? Threshold means how you increase the usage. So, those aspects will be referred to as threshold policies, pertinent issues. Interoperability. Interoperability is what? That suppose you are moving from A cloud to B cloud, then what are the key considerations for developing that? So interoperability. Okay. Then hidden cost. Yes, this is very, very important. In fact, one of you did talk about that the user may be charged for that for additional data information. So that issue is very, very important. Hidden cost. Then unexpected behavior of the system application and the service provider. Security issue we have talked about. Legal issues. This legal issue has become very, very, very important. The issue of ownership of data, very important. Then development of, suppose you develop a software in the cloud, who owns that data? And suppose there is a bug in large distributed system. So how you cater to, how you look after that bug. So that is an issue that needs consideration. Okay. Now, so let me just check this completes. E-wallet is cloud. Threshold is maximum limit. And then, okay. Application program interface. Danish, API, application program interface. Yeah. Okay. Just give me a second. Some setting to be done. Now, next is mobile computing. We'll take mobile computing from the module itself. So introduction, components, working benefits, and limitations. We have already discussed a lot on this, so let us take it from the module now. So using mobile for all things is basically mobile computing. So to that extent, it's clear to all of us. So no per se difference to be created on the definition. We are interested in the components and the benefits, disadvantages. So this is how it appears like. So the mobile and rest, the linkages, everything is clear, talked about. Let us see the components. So the key component includes the mobile communication. The mobile communication refers to infrastructure that is put in place to ensure that seamless and reliable communication goes on. So very, very important. This will include communication properties, protocols, data formats, and concrete technologies. So the communication, the way you're talking to each other, that is. Then the hardware that includes laptops. In fact, in the module, so that discussion we are having that e-commerce has merged into m-commerce. It is there, portable laptops, smartphones, tablet PCs. They are all hardwares. And the third important category is mobile software. So mobile communication, mobile hardware, and mobile software. So these three components make the whole set of mobile communication. Then how does it work so that you know working of mobile computing? The user enters or access data using application on handheld device, using connecting technologies. So you can connect through a mobile network, you can connect through Wi-Fi, send data. The data is sent to the server of the application, process, and you get your information on the mobile. There is a word that is used, RF, radio frequency technology. So whatever data that you send from your mobile is captured by what we all now hear, the mobile tower, the nearest communication tower. So that identifies the physical location from where you are communicating. That is through RF technology, radio frequency technology. Okay, now what I'll do, I'll skip this one, benefits. I'll allow you to put. So what every one of you do, put the benefit, one benefit of mobile computing in the chat. We'll come back to this later on. Let us talk about limitation. So I'm not reading benefits. Each of one you put benefit in the chat, one benefit. Okay. Then, okay. So Harsh has a question that must not be answered online. Okay. Then Pranav in 10 minutes. Yeah, you can say Pranav. In fact, it's a very good way of looking at it. If your service, I'm just taking what Pranav, let me read what Pranav has said. I'll give you a live example of that. See what Pranav says, that in cloud computing, whatever limitations or weakness of service provider are there, they will become your weakness. The answer is yes. Now what I'm doing, I'm going out of this subject and taking it to a different subject. Okay. Accounting standard 1, going concern. You know, this idea about going concern validation, what we'll be doing, we'll be merging this discussion to accounting standard 1 and multiplying this with SA 402. Just understand this. Going concern. So when you as an auditor are auditing, you are concerned with the going concern assumption of the entity. Now just understand that the entity is using a service provider who is providing the critical services. Just for example, you are an e-merchant. Okay. We have talked about this, that one of the factors which have enabled this e-merchant business to grow to such an extent in India is payment, that is digital payment. Second topic we talked about, one of the key factors is comfort, convenience, that we agreed. There was a third point called as logistics. Logistics means what? So you're ordering goods online and the delivery is being made same day. Now, someone told me that it is being delivered in 2 hours, 4 hours in metros. So what does it mean? It means that the logistics portion of that service provider network, this e-merchant, is critical to the success of the business. Now, let me do it more practically. It had happened, okay, but online we cannot share names, so let us do it like that. So there's an e-merchant. They had a tie up with a logistics service provider. All the staff of this logistics service provider say strike, go on strike. What will happen? The e-merchant's business will shut down if all the employees of the logistics service provider goes on strike. Now just understand, your auditor of the e-merchant, you are validating the going concern status of the e-merchant. But because it has a very critical operation which is being provided by the logistics service provider, the impact of the operation is such, the impact of the business combination is such that if my service provider, that is logistics service provider, doesn't work, it affects my business concern, my business continuity. So SA 402 has a huge impact. It requires validation of the business continuity of the service provider also. So when you're auditing any entity and that entity has a critical operation that is performed by an outsourcing agency, you as an auditor need to validate the business continuity of that outsourcing agency. That is answer to your question, Pranay. So of course, good questions always lead to good discussion. Okay. So you have answered benefits. Let me complete the limitation and then we'll go back to the benefits. Okay. So limitation is inefficient bandwidth. Okay, agree. Now we are already 3G, 5G, please add. So some update to the module. So now if you write, now we are getting into 5G networks also. Security standard. Yes, every service provider may have their own security standard. That is why Telephone Regulatory Authority of India, which manages all this networking, has created standards for this communication. You must be reading that. I miss that word, what they call downtime of networks. So a lot of regulation is there. Power consumption, yes. Our mobile devices go off. Transmission interference. So these could be limitations that if you're not able to run. In fact, we also find sometimes the network goes down. There may be outage of network. So you're not be able to use mobile computer. Health hazard, yes. It's a topic that is being researched across India and across world about the health hazard of the mobile radiation and human interface with device. Using a mobile sometimes may not be that comfortable because the size of the font and things are small. So that is limitation. Let us look to the advantages. So you have all given the right answer. I'll just bring it and read from what you have said. Anywhere access. Yeah, Pranav, same. Easy access, communication from anywhere. Best way of communication, easy to access from anywhere, 24/7/365 availability. Easy to access, better flow of information. We can know location as a benefit of mobile. Yes. In my case, I use mobile computing to edit my YouTube videos. Great. Great, Harsh. Yeah, lot of Uday. Mobile computing means all applications that are there on your mobile, they are mobile computing. Then Kuzema, SA 570, please write 570, name of it. Then you can use it for paying in restaurant without leaving table, hacking, enable management, improve going concern. Yes, yes. Going concern is affected in the example. That is why I told you, see, the topic we are discussing in technology, one of the most critical auditing standard that auditor needs to read through is SA 402. Please understand. Then reduce traveling time, anywhere, anytime, anywhere, anytime, anywhere, any place. Yes. Easy to operate as compared to computer. So all these aspects are benefits of mobile computing. I'm not reading them. Okay. Let me just refresh. Okay, SF. Good. So, Kusema, good. So you multiply SA 402 with SA 570 also. Yes, you have to read them together. Good. Thank you. Going concern. I missed that. Okay. Yes. So benefits I am not reading, leaving them to you. Let us go back to our slide. Okay. Then next is we have talked about this computing technology. Green computing. So introduction, best practices and security services and challenges. Okay. So we'll go to again module. So next topics are basically from modules. We'll keep on ourselves on module itself. Green refers to study and practice of environmentally sustainable computing or information technologies. Like digital payments is a green technology. In other words, it is a study and practice of establishing using computers and resources in more efficient and environmentally friendly and responsible way. Computers consume a lot of natural resources from raw materials needed to manufacture, the power used to run, and problems in disposing them. So this can include designing, manufacturing, use, and disposing of computers, server associated system in such a manner that it has no or minimal impact on the environment. So that is green technology, green computing, or green IT. Best practices. So what are the best practices for having green computing? Develop a sustainable green computing plan. Sustainable green computing plan means like you have this lot of government of India has been promoting this 3R: reuse, reduce, reuse, recycle. Reduce, reuse, recycle. So it's a sustainable technology. This you can do through including lot of people, checklist, recycling policies, encourage IT community for using best practices, have better communication on campus, how to reduce you can say in terms of carbon footprint. Then reduction of paper consumption. Yes, in fact, virtually all organizations, when they send an email, there's a bottom line written in the email: print only if necessary. So it saves a lot of paper and cost. Then use of cloud computing is also green, because then everyone need not buy a server, network, wires like that. You can share resources like that. So then recycle, that we've talked about, dispose e-waste as per regulation, discard electronic equipment in convenient and environmentally responsible manner. There are special collection locations where you can discard. Manufacturer must offer sale end life management. Recycle computers through manufacturing recycling services. Make environmentally sound purchase decisions here. So whatever you found, like you have this, we have this BES rating of electrical items, how much electrical power it is consuming, so that you can keep a tag of it. Proper performance criteria. Reduce paper consumption. Yes. Reduce paper consumption, reuse paper if possible. Both side print you can do. Conserve energy through use of, now everyone is using LCD. CRTs I have not seen since long. Thin client, that virtualization you talked about in the early part, that is basically the example of virtualization. So thin client doesn't use processors, they save a lot of time. You can create a virtual machine in your office. Use netbook rather than, notebook computers use less power. Power management facilities, if not needed, then put down systems. Try to do computer related job during intensive. Okay, so when when needed, then only keep the power on, otherwise keep the power off, like that. Green IT security and challenges. Now, what exactly is the issue? Issue is that how you motivate people to be green compliant. So green security is a new research field which involves defining and investigating security solutions. So evaluate the security mechanism to reduce energy consumption, build new security mechanism by considering energy cost. Now, in fact, you must be seeing this green buildings. Government, I missed the rating, but there is a green rating for big buildings. So the rating is given based on the availability of natural light at all locations in the building, how the heating is there. So lot of buildings are being designed, which are being referred to as green building. So that is how you use green technology. Then next topic for discussion is BYOD, but there is some queries. Okay, mobile computing. So God is omnipresent, omniscience, omnibenevolent, and omnipotent. Great, Manoj. I learned the words. Thank you. Yes, green is more focused on the hardware part. Yes, yes, Pranam. Good. BYOD, bring your own device. So, what exactly is the issue? So, like we talked about companies having 3 lakh employees and they create their own private cloud, and now people are going to access private cloud. So, do the company give 3 lakh employees 3 lakh laptops like that? So, what companies have started doing, they allow employees to bring their own laptops. So from the own laptop, the employee, he or she is going to log into the computer's cloud or the company's cloud. Now I've just shared the basic definition. BYOD is that allowing employee to use his or her own laptop to log into company's database or company's private cloud, as we have talked about. You write the risk. So BYOD, bring your own device. I am an employee of a company. I take my laptop, go to my seat in the company, log in through my laptop to the company's database and start working. This is a basic definition of BYOD. Just with basic definition, I want you to write the risk that you see that BYOD may be bringing. Okay, so write the risk. Okay, so it refers to business policy that allows employees to use their preferred computing device like smartphones, laptop for business purpose. It means all are welcome to use personal devices to connect to corporate network to access information and application. The BYOD policy has rendered workspace flexible, empowering employees to be mobile and giving them the right to work beyond their required hours. So that is how people can use and work on this. Advantages. Happy employees because they have to use their own device. The comfort of using the device is very high. For organization, they need not buy a separate laptop for each employee. Reduce support because employee he or she is carrying his or her own device, so that requirement is not there. Early adoptions. Employee may are proactive as individuals to adopt to new technologies, so they come and improve working efficiencies. Now, emerging BYOD threats. So let me read the threats from your answer. Data loss, data missing, data security, chance of hacking, data theft, hacking, internet not availability, data theft if device, leaking of data outside premises. Yes. Okay. So let us read. Network risk, lack of device visibility. It is normally exemplified and hidden. When company-owned devices are used by all employees within the organization, the IT practice has complete visibility of the device connected. This helps to analyze traffic data. As BYOD employees carry their own devices, the IT practice team is unaware about the number of devices being used on the network. But then you can use technology to keep a track. But then the issue is valid that third-person devices are connected to network, so visibility becomes critical. For example, if virus hits the network, all devices connected to the network need to be scanned. So because it's an employee device, direct identification is tough. Device risk. Suppose the device of the employees is lost by theft. You all said data theft. So the theft of device leads to theft of company's data. Application risk. Yes, malware risk on the device of the employee. Implementation risk, it is normally exemplified and hidden in weak BYOD policy. If companies don't have a BYOD policy, bring your own device policy. The effective implementation of BYOD program should not only cover the technical issue, but also the implementation of corporate security, because it's a third party system. One point I want you to add here, companies have started giving employees what is now being called as a BYOD allowance. See what is happening? Companies not expending money on the hardware, allowing the employee to use his or her laptop, desktop. So there is depreciation we have read. Okay. So it's on a flux of time, wear and tear. So this employee, the laptop, desktop, or sorry, laptop or smartphone is going to be depreciated. So companies have started giving employees something called as a BYOD allowance also. So it's a new word. Something is evolving. It is nominal, but it's an incentive to the employee to bring his or her own system. So just read that. Then Web 3.0. Let us complete the questions. Hacking, yeah, okay. So Web 3.0 is also known as semantic. Semantic means logic. Describes sites wherein computers will generate raw data on their own without direct user interaction. Web 3 is considered as the next logical step of evolution of internet. First, internet was confined to homes, but now it is all omnipresent. So underlying concept. So Web3 standard uses semantic web technology, drag and drop mashups. Means basically what you're doing, allowing technology to understand, do things. So it is based on basically AI-based technology, allowing data to be analyzed. An example of typical Web3 application is the one uses content management system along with AI. These systems can answer the question posed by users. I think the best example is all this bot help or chatbot help. So that is good example of Web3, where you ask a question and the bot responds to the question. Components is semantic web, they're logical. This provides web user common framework that could be used to share reuse data, and web services through which you are going to use Web3. IoT, we have talked about Internet of Things. Semantic is logical. So Web3 is use of technology to create this artificial, you can say, interface devices to the user. So you give something to it and it programs, it answers. To conclude, Web3 helps in achieve more connected, open, intelligent applications using concept of natural language processing, machine learning, reasoning. As technology evolves, new applications come into being. So the example I give, that chatbots, you go to any bank, private sector bank, public sector bank also. IRCTC also has a chatbot named Disha. So you can go there, and so these are good applications of how Web3 is evolving. So Web3 is technology component that is interacting with users, where there are logics built into that. In fact, it is there on all chatbots will fall in that. Then IoT, we have talked about Internet of Things, where your electrical devices are connected through Wi-Fi and they can talk to you, discuss with you. They can communicate their status on your mobile if that application of that device is downloaded on your mobile. We have talked about this. So these are the applications. Homeowners keep track of home security system, office machines, government under Swachh. Yes, this is good. Under Swachh mission, government has tagged dustbins. The dustbins generate a message once they are full. So there's a weight measurement sensor at the bottom, height measurement, like that. And it is connected to Wi-Fi. So the municipal corporation gets an intimation that this device is filled. Then wearables, smart city. So these are all applications for IoT-based systems. Like this traffic signals. So if there is no car there on that lane, or the volume is high, so you allow a larger signal time so that the cars cross. Smart grids, this you must have seen this electricity smart grid. So that is also application of IoT. Industrial application of IoT for power generation. So what is basically being done? All your devices are being connected through communicate so that their status is tracked by you. So those becomes IoT. In logistics, we talked about this vans delivering ice cream, butter across the country. So they have got this devices which keep track of every status of the van and the product inside the van. Connected cars, yes, internet insights, all these things are good examples of web technology, this IoT. Connected health devices are there inserted in body of individuals, connected through app and their mobiles. Smart retail has started adopting IoT using embedded systems across applications that help improve operations, reducing theft, enabling inventory management. You divide this, the racks where the products are kept, those racks are being connected through IoT. So they keep an automated inventory of what is available, what is not available. Phenomenal. Then smart supply chain on the road that we have talked about. Risk. The nature of risk is based on practical experiences. Risk include risk to product manufacturer, impact on business. Yes. Manufacturer may be out of business in few years if IoT. See, IoT has already become a necessity. Huh? Please understand. It's already getting into this range of becoming a necessity on few products. Data storage analytics, because you will be using IoT, so that becomes huge data issue. This is a live example. The companies are not named, but this is a live case has happened somewhere outside India. So just understand what was the case. A company manufacturing, let us take example, manufacturing a washing machine. B company is also manufacturing a washing machine. B company acquires A. So now it's an amalgamation. So A is merged into B. The washing machines by A are IoT enabled. The washing machines by B are also IoT enabled. But because the manufacturer was different, the technology, the software are different. So as A is bought by B, after 3 months of the sale transaction, B stops giving maintenance updates to washing machines sold by A. Please understand it's a live case and no one knows how to get about this issue. So that is a big risk. Then security, privacy, autonomy, control. So these are also risks that is there to this technology. Technology risk, environmental risk due to technology. So whatever you're using, so that risk is created. BOS, yeah, good. Connected car, Tesla. And now we have got this, lot of Indian cars are also getting connected. Okay. AI, artificial intelligence. So we all know. So we all have been using this AI-based machines, your Apple Siri, Google Talk, Alexa. These are all AI-based solutions. So where you allow technology to shape decision making, shape reasoning, that is AI. Application side of AI is machine learning. So it's a science and art of programming computers so that they can learn from data. It is a subset and application of AI. So machine learning is the next level, okay, of artificial intelligence. Applications, yes, this you all know. Autonomous vehicles such as drones, self-driving cars, medical diagnosis like cancer, rating. So this you can all read. So these are application side of artificial intelligence. Playing games, yes, chess. In fact, I'm Gary Kasparov and I miss the other chess player name. One of the two, I think probably Gary Kasparov. He was the world chess champion from Russia 35 years back. So that time IBM developed a computer. So this Russian world champion of chess, he had a match with that IBM computer which was playing the chess. I'm asking you this. So that now chess has 64 board, 64 cells to fill. So this supercomputer that was built to play chess with the world champion then 35 years back. So it was given some capability of analyzing, say, 10,000 or 25,000 moves based on one move made by the chess player. I am allowing you this of that first match that Russian world champion had with the supercomputer built to play chess. Who won the first match? You'll be surprised to know the first match was won by the human being, because he is a human being. The capability that he, his mind has is phenomenally more than that supercomputer also. But then over a period of time, this concept of AI evolved. So what artificial intelligence is able to do, keep track of the way things are moving. So that reasoning part is very high in artificial intelligent devices. Yes, player one. The first match was won by the human being. It's a phenomenal story to know. Okay. Then rest are easy examples. Just carry them. Real-time quotations, match results, detecting unusual. Yes, these companies are doing. In fact, all big e-sellers, e-merchants have this detecting unusual transaction trail. I told you about that mobile phone being returned 20 times in a year by a single person in a single city. So these AI-based technologies are used. Solving complex problem, training humans for complex problem, discovering hidden patterns. So these are where AI is being used. Okay. The risk, because AI puts lot and lot in input data, incorrect input can lead to disastrous result. Then with growing technology, increased dependence of humans on AI is there. Yes. So AI can provide critical functions. So the attack on AI algorithm can hit those critical functions, banking, medical, robotics. So it's some, because the way technology is being integrated into day-to-day life, the risk goes so high. AI in long-term may kill human skills. Yes, so it's the way it is. Then you need to have proper controls in AI. The new topic that is blockchain. Yes, Pranam, I am with you. AI cannot cross human capabilities. Yes, Harsh. I mean, they're very good movies if you see those on AI based technology. Okay. Then blockchain. So blockchain is sometimes referred to as distributed ledger technology. Someone did ask you this question. So that is here. So blockchain is also referred to distributed ledger technology. It's a shared peer-to-peer decentralized open ledger of transaction system with no trusted third parties in between. This ledger database have every entry as permanent, as it is an append only. Append only means you can only add database which cannot be changed or altered. Okay, append only means you can only add to that. Okay, so if you can only add, that means whatever is coming is an addition. There is no change to that database. All transactions are fully reversible, with any change in transaction being recorded as a new transaction. So if any change is there, then it changes the whole transaction. The decentralized network refers to network which is not controlled by a bank, corporation, or government. A blockchain generally uses chain of blocks, with each block representing digital information stored in public database. So the whole data is brought, broken in blocks and stored separately. A simple analogy for understanding blockchain is a Google Doc. When we create a document you can share with group of people, the document is distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to document at the same time. No one is locked out awaiting changes from another party. While all modifications to the document are saved and recorded in real time, making changes completely transparent. So how does blockchain work? A transaction like sending money to someone is initiated. Transaction is broadcasted via network. The network validates the transaction using cryptography. So whether it is valid or not, you create ciphertext. The transaction is represented online as a block. Block is added to an existing blockchain and the transaction is considered as complete. So that is how this blockchain technology is going to work like. Applications, financial services, it is being used. Blockchain can be used to provide an automated trade life cycle, say in terms of asset or property, physical or digital, healthcare, government, they are already into this. Huh? So healthcare blockchain provides secure sharing of data in healthcare industry by increasing privacy, security, interoperability. Government is started saving this land registrations, vehicle registration through blockchain, travel industry, economic forecast. So all these have started using blockchain to store their data. Risk with use of blockchain, organization need to consider with a wider perspective as different members of particular blockchain may have different risk appetite. Yes. So people using blockchain, they like we did talk about that everyone is going to have their own risk tolerance, risk perception. So that need to be standardized. And who is responsible for managing that? Reliability of financial transaction on blockchain is dependent on the underlying technology. So if underlying technology is tampered, the issue will go to blockchain. This could refer information stored in the distributed ledger as inaccurate. In the absence of any central authority, so there has to be a central authority for managing this blockchain. What are the protocols they need to be complied with? As blockchain involves humongous data getting updated very fast, risk related to information overload need to be managed. Controls, there could be many ways. As opposed to manual technology, computerized continuous monitoring technique has to be done. We talked about those audit techniques. Suitable data analytics has to be done on what is happening. Communication methods need to be secured. The unique aspect of blockchain, such as consensus protocol, smart contracts, private keys, as well factors relating to the health governance issue, reliability should be assessed thoroughly. External, internal auditors shall be engaged to ensure development and identification of blockchain is appropriate and controls placed to mitigate the risk in blockchain. Then case studies, this we have talked about. Okay. So I'll request you to go through the case studies on your own. Yes. So before we end today, any questions? And then next classes are from is on 15th, 17th, and 19th. There is some reschedulement. So 15th, 17th, and 19th. Yeah. So just before we close, any questions on the day? Double century, Danish. Good. Yes, crypto is running on blockchain. Only 3 sessions. Yes. Last chapter, chapter 5, core banking system. Okay. Any questions on today's topic? Yes. It is, Manoj, it's already there. Okay. We'll take MCQs, start of the next session. Yes. Okay. So take your call on the percentage of results on your own. Thank you. Okay. So let us call it. We are closing. Thank you. Good night. So we have crossed double century. Thank you.